The entire ocean is recycled through hydrothermal vents every 10 million years. Earth's tectonic plates float like bath toys on top of a massive liquid mantle. In some places, they expand and create vents, volcanoes, and new seafloor. In others, old seafloor is destroyed. The ocean itself also cycles through the hydrothermal vents at these borders every 10 million years, which is what gives the ocean its salty taste. At research sites around the world, scientists are trying to unravel the mystery of the deep vents. Like those in the Galapagos Rift, each one holds more clues, but in an ocean covering almost 140 million square miles, it will take decades for more scientists to find all the answers. Scientific revolutions happen when we stop seeing the world we expect and start seeing the world as it is. The incredible biological world of the vents may never have been discovered had scientists not been trying to solve a geological puzzle. Today, we know that Earth's crust is broken into great slabs called plates that travel across the planet's surface as though on some sort of slow moving conveyor belt. The complex interaction of these plates is called plate tectonics, and it is the force behind mountain building, volcanic and earthquake activity, and the slow reshaping of Earth's continents and oceans. Back in the 1970s, though, this idea was still in its infancy, and the biggest question was what powered this belt. Geologists reasoned that the only heat source powerful enough to move continent sized blocks of Earth's crust was liquid rock or magma in the mantle. At places where two plates were pulling apart, known as spreading centers, geologists thought that the heat from the mantle would break through as a sort of exhaust system for Earth's core. Finding that heat would be an amazing geological discovery. In the early 1970s, during a search on the Mid Atlantic Ridge, scientists found lots of evidence for plate tectonics, but none of the hot water they were expecting. Undeterred, geologists John Corliss and Bob Ballard decided to try again in 1977 on a mission funded in part by the National Geographic Society. This time, they were looking in the Pacific in an isolated area known as the Galapagos Rift. Spreading along the Galapagos Rift is much faster than it is along the Mid Atlantic Ridge. The hope was that the faster moving areas would release more heat and generate more vents. They had no idea how right they were or what this would mean for studying the deep sea. Before that day in February, biologists had reason to believe that the deep ocean was an almost lifeless desert populated by a few scavengers that might be able to live on the remains of animals or plants that dropped from the surface.